Hello everybody, this is Omar Ashraf from Team Bshyaka, and in this video my colleagues and I are going to explain our project for the Embedded System course. The main objective of the project was to create a smart attendance system using the Arduino board with some sensors and LCDs in order to enhance the attendance process and to make sure that the students only take the attendance if they attend 75% or more of their tutorial number. I'm going to give a rough explanation about the project, and later on in the video my colleagues will explain everything in detail. However, the main idea was to use ID readers that both the TA and the student use. When the TA swaps his ID with the reader, the session automatically starts and the attendance starts being counted. And as long as students attend 75% of the course, the attendance should be met, and then a text file is made with the attendance and the absence sheet. The session ends when the TA leaves the room using his ID reader again. However, in case of an emergency, we have a smoke sensor that senses any smoke in the room and automatically opens the doors and allows the students and the TA to leave safely. And now I'm going to leave you with my colleagues to explain the rest of the project in detail.
Hello everyone, my name is Khalid Hassan and I'm going to talk about the component that we use in our smart attendance project. First of all, we use the Arduino Uno board that had the Atmega 328P microcontroller embedded in it. We use an MFRC522 ID reader, LCD screen, a smoking detector, a buzzer, green LED, red LED, potentiometer, ID cards, and a tag. For the MFRC522, it is used to scan the ID cards or the tag for the students or for the TAs. The LCD screen is used to display the number of students that are currently inside the class. The smoking detector is used to detect any fire or any smoke that are inside the classroom. The buzzer is used in case of fire, where it produces a sound in case of fire. The green LED is used to simulate the opening and the closing of the door. If the green LED is on, it means that the door is open. If the green LED is off, it means that the door is closed. And the red LED is used in case of fire, and it will produce a flashing light. The ID reader, the ID cards will be used by the students to control the door and to be able to control their attendance. And this tag is used by the TA only to be able to start and end the session with. Now my colleagues will explain to you how these components are connected and how we use these components to build up our smart attendance system.
Hello, I am Karim Nashat. I worked on the fire system, the whole fire system in our project. Our fire system consists of a fire sensor and a buzzer and a red LED. The fire sensor senses the smoke in the environment, and our Arduino changes the analog value that the fire sensor reads into a digital value, since we are connecting the fire sensor to an analog to digital pin. We have in our code a threshold value, so we keep checking if the digital value that we read from the fire sensor is less than the threshold value. This means that there is no fire or there is no smoke. If the digital value that we read from the fire sensor is greater than the threshold value, this indicates that there is a smoke and there is a fire. When there is a fire, the buzzer goes on, producing sound, and the red LED keeps turning on and off to indicate that there is an emergency and there is a fire. One thing related to the fire system: when there is a fire, the LCD writes fire emergency, and the door of our class opens, which is indicated by the green LED. When the green LED turns on, this means that the door is open. So when there is a fire, the green LED turns on, and it does not turn off to allow the students to go out as there is a fire.
Now, as Karim has explained how we connected the components of the fire system, so we can try it now. Once the smoking sensor has detected that there exist fumes or that exist a fire inside the classroom, it will send a high signal for the buzzer to produce the tone. It will send a high signal for the green light to open the door, and it will send a high to low signals for the red light to flash.
Hello everyone, this is Khalid Ahmed from Team Bshyaka, and today I'm going to talk about one of the most important components that we have used in our smart attendance project, that is the LCD screen. My colleague Omar Ashraf and I were responsible for this part of the project, and to begin we started with the connections. Pins 1 and 16 of the LCD screen, which are the VSS and the K, are connected to the ground row of the breadboard, while pins 2 and 15, the VDD and the A, are connected to the 5-volt row of the breadboard. Furthermore, we use something called a potentiometer, which is a varying resistance used to set the contrast of the display. For its connections, there is its first pin that is also connected to the ground of the breadboard, while its middle pin is connected to pin 3 of the LCD screen, that is the VO. After further connections, the LCD is ready to function, and we start writing the code. For the code part, we used the liquidcrystal.h library to be able to display the required messages for our scenarios that go as follows. When the TA enters the classroom, there is a message displayed that says that the session has started, and when the TA leaves, that's when they scan their ID before leaving. There is also a message that says that the session has ended. Same would go for the students. When a student enters the classroom, there is a welcoming message that says welcome, followed by the student name, and when a student leaves, there is a goodbye message that says goodbye. For the cases of the emergencies, as in the fire, when a fire occurs, there is an emergency message displayed when the buzzer goes off. And for the most important part, that is the student count, each time a student enters the classroom, the student count is updated, that is incremented by 1, and displayed on the LCD screen.
Back again. My main responsibility was to connect the connection of the RFID with the Arduino board. The RFID has 8 pins, in which 7 only pins are needed to be connected, and 1 pin is disconnected or not connected to anything. The only difference between this component is that it has to be connected to the positive 3.3 voltage of the Arduino board, not the 5 volt. We defined this tag to be the tag or the card or the ID for the TA, in which it can start or end the session with. So if we sweep out this ID, the door LED is open and it will display that the TA has entered and the session has started. Once the session has started, we will save the time where the TA has entered in the class in our code to be able to calculate the attendance for the other students.
The student attendance will be calculated using the same ID reader used for the TA. The student is free to come before the TA enters, but the attendance won't be calculated except when the TA comes. Initially, when the student comes, the door is closed and it won't be opened until the ID is scanned. So now let me show you practically how the process goes. When a student arrives, he scans his ID. Initially, the screen is showing that the class is empty. When the student scans his ID, the screen will show his name and the count will be updated, and we simulate the door using this green LED. So when the door is opened, it will lit. Let's see it again on another student. When the student arrives, he scans his ID, the screen showed his name and the green LED lit. Now let's see and the count here is updated. Now let's see when one of the students will go out. Here the screen will say goodbye and the LED will lit again, and the count is updated.
Once the TA has finished the tutorial or the class, it will sweep out the ID again. It will say that the session has ended and the door will open again. In our code, we will keep track of the time where the TA has left or the session has ended to be able to calculate the time for the time for or to be able to calculate the attendance for the other students. Now we have finished the hardware part, so let us go to see the software part. First, we included the required libraries, which are liquidcrystal.h to be able to use the LCD screen, and the SPI.h and MFRC522.h to be able to use the ID reader. We created the class student where it has 6 attributes, which are the ID, the entrance time, leaving time, time attended, Boolean entered class, and a Boolean attended. The constructor takes only the ID of the student. We created like a small database that has 4 students by creating 2D array of charts to save the student names, and by creating an array of type student, which is the class that we implemented above, and inserted into this array 4 students, each having different IDs. We extracted the first byte only of the UIDs that we used to be able to be the IDs of the students instead of having an ID of 4 bytes, since they were all unique. We defined also a specific ID for the TA along with some attributes and variables that we will use in the code later on. We connected the green LED that simulates the door is open or closed to pin number 2 on the Arduino board. The buzzer is connected to pin 3. The red LED is connected to pin 4, which flashes when there exists a fire, and the smoke sensor is connected to an analog pin A5 on the Arduino board. Here we define the smoking sensor threshold to be 200. We created an instance from the MFRC522 ID reader, which takes the SS pin and the reset pin, which we connected them on pin 10 and 9 respectively on the Arduino board. An instance of the liquid crystal is created, and the pin numbers that the LCD is connected on in the Arduino board is passed in its constructor. The setup method was used to set the direction of our pins. We set the LEDs for the door and the fire to be in the output. Also, the buzzer is set as an output, while the pin that is connected to the smoke sensor is set to be an input. The baud rate is set to be 9600. In the loop method, we call the method attendance that I will explain later in this video. We read the analog reading of the smoking sensor and checks whether this reading has exceeded our threshold, which is 200 in our case. If yes, then this indicates that there exists a fire inside the room, and call the fire method. In this method, it will set a high signal to the door LED to open the door without the need of any IDs. The buzzer will produce its emergency tone, and the emergency LED will keep on flashing. Now I will explain the attendance method that me and my colleague Yara have implemented. First of all, the ID reader will check if there is any card that is currently scanning. If not, then it will return. The second part, the ID reader will return if it wasn't able to read the card serial correctly. For this line, the read card variable is loaded with the first byte of the scanned ID only, as all the IDs that we used have unique numbers for their first byte. We have two cases, whether the scanned ID is for a student or for a TA. Yara will explain to you if the scanned ID was for a student later in the video. So let me explain now the case where the scanned ID was for a TA. First of all, it will check whether the session has been started or not. If the session hasn't been started, then it will execute the first if statement, which indicates that the TA is entering the class to start the session. First of all, it will write on the LCD screen that the TA has entered and that the session has started. It will also turn the session started to true, the Boolean of the session started to true, and will set the variable of the TA start time with the time that the TA has entered the class. Regarding this for loop, It loops through the array of students only to check whether there exist any students entered inside the class before the TA has entered or not. If it is the case, then it will set the entrance time of the students in class with the TA entrance time, and a call to open door method is performed, which basically the open door method basically turns on the LED of the door to high for 3 seconds and turn it back off. Back to the attendance method. This else part is executed when the TA is leaving. When the TA is leaving the class, which means that the session has ended. It will write on the screen that the TA has left and that the session has ended. It will return the boolean of the session started back to false, and it will reset the students count back to 0. The TA and time variable will be loaded with the time that the TA was leaving in the class. That the TA was leaving the class in. It will then calculate the session time by subtracting the time where the TA left from the time where the TA entered the class. The minimum session time is calculated by multiplying 0.75 by the total session time, which basically the 75% of the total class time. It will also set the Boolean flag of the session ended to true. As for this loop, it will go through the array of students and check if the students was inside the class when the TA was leaving, and if it was the case, then it will set the student leaving time to be the same as the TA end time or the session end time, and will calculate the total time attended of the student by subtracting the leaving time of the student from the entrance time of the student. As for this loop, it loops through the array of students also and check whether the time attended inside the class of this student was greater than or equal the minimum session time, which is the 75% of the total time of the session. If yes, then the student will be counted as attended, else the student will be counted as an absent for this session.
So now let's take a look at the part where the students can scan their ID. Here we loop on every student and check if the scanned ID belongs to this student or not. If it belongs to this student, we enter the if here. We want to check if he is entering the class or he is leaving, so we check our attribute that's called entered class. If it is false, this means that the student is entering the class. So here we write on the screen welcome and the student name, and the student count is incremented by 1 because now a student is entering, and the count change is equal to true, so we can update the screen. And we change the entered class attribute of this student to true, and we calculate his entrance time. So entrance time is equal millis because this is the time he entered the class, and we open the door. Here the else part, if the entered class attribute was true, this means that this student was in the class and he is leaving now. So we will write on the screen goodbye, and we will write his name and decrement the student's count and set the flag of count change to true in order to update the count on the screen. And we change the entered class attribute of these students to false, and we calculate his leaving time. Here we want to calculate the time attended, the time the student attended the session. So here the time attended is equal to the time attended plus leaving time minus the entrance time. Here we added time attended again because the student can enter and leave and enter the class many times. So we should calculate the total time he was inside the class. And we open the door.
We use a software that logs all what in the serial monitor in a text file to save the attendance records of the student.